Okay, so we're going to finish up here and start talking specifically about direct or the PC relative addressing mode, and look how we can do that address calculation on the simplified LC-3 data path. So over here I have drawn the address adder, the two address adder multiplexers, the marmux, the PC, and then the memory down here with the MDR and the MAR. So first thing that we need to think of when we're looking at direct or PC relative mode is we can think of a sample instruction like load. So for load, the register transfer notation is that the destination register gets the memory of the PC plus the offset 9. So in this case, the effective address is going to be PC plus offset 9. So that's what we're going to take a look at now, trying to calculate. So we want to just get the value that's in the PC and then add it to the sign extended offset 9, or remember that can also show up as the instruction register 8 through 0. So we're going to go ahead and list the control signals that would accomplish that in this data path. So remember, all we're trying to do is add the PC to the sign extended offset 9 and then get it into the memory address register, or the MAR. So first thing that we need to do is just look for the two things that we need to add together, which is going to be up here, the PC, and then down here, the IR bits 8 through 0, or the sign extended PC offset 9. So you can notice that this value goes into this first multiplexer, and then the PC goes into the second multiplexer. So whenever we want to get our data through a multiplexer, we have to send a control signal for that to accomplish that. So our first two control signals are going to happen at the same time, or maybe one after the other, but either way it doesn't matter. So we can write it as the address 1 multiplexer selects the PC. And then we could just do the same thing for this multiplexer right here. So that one we would call the address 2 multiplexer. And that one's not going to select the PC. It's going to select the instruction register bits 8 down to 0. So at this point, what we've accomplished here is we've had this multiplexer select this value, so that goes down to this other side. And then we've also had this multiplexer select this value, so it's right here. So now this adder, if you remember from class, adders don't need control signals, so whenever it's presented values, it's just going to go ahead and add them together, and then it'll show up at the output after a certain amount of time. So the next thing that we need to do in order to get this part to the MAR is we need to let it through to the system bus and then load it down here. So this is another multiplexer that we need to open in order to get it through. So we need to send a signal to that multiplexer, and we can call it by its name and say the marmux selects the address adder. So at this point, we've had the multiplexer select the address adder, so it's right here. If you remember from class, whenever something wants to write to the system bus, we have to send another control signal, a gate control signal, so that multiple things don't try to write to the bus at the same time. So here we can name this gate after what comes right before it. So we can send a signal gate marmux So now our PC plus the offset 9 is on the system bus. So it's on the system bus. So the last step that we need to do is we just need to get that into the MAR. And how we can do that is by sending a write enable signal to the MAR. So our last control signal is going to be load.mar.